In this next section, the directions say to find each limit using L'Hopital's rule when applicable. Make sure you show why L'Hopital's rule is applicable if you use it. So we do need to show that we'll get 0 over 0 or infinity over infinity if you are going to use L'Hopital's rule. And I'm going to put right up at the top that LR stands for L'Hopital's rule. So if I use an abbreviation, it is legal. Alrighty, so if I plug pi in here, we'll get cosine of pi over 2 divided by pi minus pi. The cosine of pi over 2 is 0. Pi minus pi is 0. So I just now showed that L'Hopital's rule is applicable. So we are now going to use L'Hopital's rule. So we'll find the limit as x approaches pi of the derivative of this. The derivative of cosine is negative sine of x over 2, but this will be negative 1/2 x over 2. And then the derivative of x is 1, the derivative of pi is 0. So now when I go to plug in pi over 2, I'll get negative 1/2 sine of pi over 2, over 1 of course. The sine of pi over 2 is 1, so negative 1/2 times 1 is negative 1/2. Great, the next one we've got the limit as x approaches 1 of x minus 1 to the negative 1 over ln x. If I want any chance of being able to use L'Hopital's rule, I definitely need to have a fraction. So I'm going to rewrite this as ln x over x minus 1. So now I'll try to plug in 1. I'll get the natural log of 1 over 1 minus 1, which is 0 over 0. So L'Hopital's rule is applicable. So if I use L'Hopital's rule, this will now be the limit as x approaches 1. The derivative of ln x is 1 over x. The derivative of x minus 1 is 1. And then from here, if I go ahead and plug in 1, I'll get 1. So my answer is 1.